Okay, so let's do a quick demo. So you have two options. First, you can just drag and drop browsing files, uploading the documents, and I think it's 200 meg size, the cap, and the PDF file, MP4 file, basically it's a PDF or the video. Now I already have one. So it's MP4 file, and so the idea, the interesting thing is how is the document is stored in a video format. So that's I come across this thing, a very interesting document that the GitHub repository called MEMVID. So what it does, it's using, we all know that the video compression, right? So the idea is why not using the same concept? Let's break up the text chunks rather than storing a traditional vector database like Pinecone or the FAISS. Let's store in an MP4 file format. And what the benefits you get? The benefits is you can store and retrieve in blazing fast. Also provide you with a semantic search capability. So that's all it does. So when I saw that, I said I have to build a demo out of it. So I already did that. So first you're uploading a PDF file, so which is wrap up all our AI use cases, and it's automatically break the text chunk and storing an MP4. So now I'm just going to uploading it, right? Loading from the memory rather than have to have the large language model and spend a fortune on it to store in a MP4, MPEG or MP4 all over again. So I did that, save us a lot of time for the demo purpose. Now I can do the retrieve piece. Right? I ask like a simple question: is to all the insurance customers using Appen AI? So it try to pull all the semantic search from our AI use cases knowledge document, and here is all the documentations, all the results back. So that's good. That's an agent. Basically, you say, can I find it from the context from the document you give me? Now, what about, I cannot retrieve anything relevant from the knowledge base you provided, then what my fallback strategy? So luckily, I'm building a fallback is using conduct a web search. So the web search, basically, it goes to the internet and looking for this term, and it come back. So the technology I'm using is DuckDuckGo, and the large language model I'm using is Grok. So here is the, if it's found and retrieved from the context, it will give it an answer. And if it's not, it will using the backup agent to do the web search. Now let's switch to the Galileo AI platform, the console. Here is the first test run, which is very straightforward. Here the agent using the document retrieval, and then send out to the agent here for the file chat, and is there fallback, which is not, because it's able to retrieve everything from the document. Pretty straightforward. And what impressed me the most is the matrix here. Here is the matrix, and the agent execution have another set of matrix. And here is that out of box come with I think a dozens of the matrix, and you can pick. And also you give you the capability, you can design your own custom matrix for your own bespoke large language model driven applications. So let's take a look at a couple. Here is I think the 4 I picked, but if we go security, the prompt injection should be on everybody's measuring. And prompt quality, there's another good ones. Let's take a look. Safeties, of course, and here the RAG. I picked 2 of the RAG, and the agents, I picked 4 out of the 6. This is the feature I think is really cool. But also you can view the latency and the message. And the message including, here is including all the matrix it has been picked, like say auto completion and context adherence. The instruction, that's for the agent specific measurement. So here you see it's a fallback decision. and it says it's to agent is sent to the agent which is planned to do, set to the web search because no answer was found in documents. To give it the reasoning, and then send out to that agent which is a web search. Fallback triggered is true. That's quite good. Overall, to cap, leveraging the Galileo.ai platform enables organizations to efficiently evaluate, monitor, and optimize the performance of their AI applications.